Hello, in this video we will discuss the mathematical and real-life applications of a hyperbola.
This is a vertical transverse hyperbola. The equation is y squared over a squared minus x squared over b squared equals 1. Y squared is the range, x squared is the domain, a squared is the length of the major axis, and b squared is the length of the minor axis. The asymptotes are y equals negative a over bx and y equals a over bx. The two foci are 0a and 0 negative a.
Rectangular hyperbolas with asymptotes on the x and y axes follow the form x minus h times y minus k equals 1 equation to move the hyperbola. Hyperbolas with perpendicular asymptotes are known as rectangular hyperbolas. When a hyperbola uses the x and y axes as the asymptotes, it follows the form x minus h times y minus k equals 1, where h and k are the x and y values of the center.
The first example of hyperbolas in real life is a cooling tower. As you can see, there's a very clear hyperbolic shape, which makes it so that you need less material to build while still keeping it structurally sound and providing excellent airflow.
Another example of how a hyperbola is related to real life is a lampshade. When it is set up against the wall and turned on in the dark, two hyperbolic curves are formed on the top and on the bottom of the wall. This is because when a vertical plane slices a cone, the result is a hyperbola. For example, here is the light bulb, and then there's a wall, and then it cuts across the light, forming a hyperbolic curve, shown here.
Another example of a hyperbola is when two rocks are simultaneously thrown into water. They create concentric circles which intercept to create hyperbolas.
When traveling at supersonic speeds, aircraft create cone-shaped shockwaves, like so, which, when at the ground level, create hyperbolic shockwaves because the ground acts as a plane which is cutting off a cone, creating a conic section of the original shockwave, which forms a hyperbola.
To derive the equation for a hyperbola, you must start with the definition. The definition of a hyperbola is the set of all points whose difference of their distances from two given points, called the foci, is constant. For this example, we will be using a center of 4, 4, a focus of 0, 4, and the other focus will be 8, 4. The difference of focal radii will be 6. In order to derive the equation, we must look for all possible values of point xy.
To start, we used the distance formula to find the distance from point xy to the first focus. We did the same for the second focus. We then set up an equation where the difference of the two expressions of distance was equal to 6, the difference of the focal radii. We then moved the negative root to the other side of the equation in order to make it positive, and then we squared both sides.
After canceling out unnecessary values and combining like terms, both sides of the equation were divided by 4 in order to simplify. Then, we squared both sides of the equation to eliminate the radical. We distributed the 9 to the values within the parentheses.
We combined like terms to make it a lot shorter. In order to begin making a perfect square trinomial, we factored a 7 out of the x and x squared terms and a 9 out of the y and y squared terms. In each parentheses, we added a number in order to complete the square. In this case, we added 16 in both parentheses. These numbers had to be multiplied respectively by 7 and negative 9 before being added to the right side of the equation. After simplifying, we factored the perfect square trinomials into squared binomials.
Lastly, we divided both sides of the equation by 63 so that the right side would be equal to 1. Therefore, the equation followed the standard form x minus h squared over a squared minus y minus k squared over b squared equals 1.